Hi, my name is Matt Deitch, and I'm an assistant professor with the University of Florida in the Soil and Water Sciences Department. My office is located at the West Florida Research and Education Center, right about here in Milton, Florida, at the far west end of the state, where I study hydrology and watershed issues here in our region, especially in the Florida Panhandle. And for those of you who don't know, this is a pretty exciting place to study water resources for a number of reasons. Among them is that we get a lot of rain in this area. This is a map showing the distribution of rainfall over the southwestern U.S., especially in this Florida, Alabama, Georgia area. We get a lot of rain here. It's a pretty exciting place to work this time of year. We get lots of thunderstorms moving through, big storms. In this area, on average, in an average year, we get around 65 inches of precipitation, which is about twice as much as like the Midwest, twice as much as the East, as much of the Northeast. So it rains a lot here, and these storms the storms that produce this precipitation tend to come in very big events, which I'll talk about in a little while. I do most of my work here in the Pensacola Bay watershed and the Perdido Bay watershed. The city of Pensacola is right about here. Let's see, I'll get my pointer stick here. All right, the city of Pensacola is here. This is, if you're at all familiar with the area, Gulf Breeze and Navarre, right along Santa Rosa Island in this area. This black outline shows the watershed boundary for the watershed of the land that feeds down into Pensacola Bay. The reason why I show this is just to kind of underscore the effects of urban areas are going to be especially pronounced in this lower area, because that's where most of the urban area in the watershed is located, in both the Pensacola Bay watershed, this one here, and the Perdido Bay watershed, this over here. There are a few cities around here like Andalusia and Bruton, but most of the development is down in here: Pensacola, Milton, Pace, Gulf Breeze, Navarre. And just for reference, we're located, this yellow box here is the same as this yellow box here along the Gulf of Mexico. I'm working in this area around Santa Rosa and Escambia counties because we're concerned about the extent of flooding in this area and trying to find ways that we can reduce the flooding that occurs as a result of this rainfall, with the idea that some of this flooding may be attributed to the effects of urban development in this area. And just to kind of get an idea, this is our stream drainage network. This is kind of what the U.S. Geological Survey, the agency that kind of organizes and keeps track of streams and the movement of water through the area, what they've identified for their drainage network. We can see in the urban areas, actually a lot of the urban area, like in Pensacola, there aren't many streams. So there's not a whole lot of streams in this area, and that's partly because they've been buried historically. A lot of the streams flow or are now contained in subsurface culverts and things that convey water subsurface underground through underground tunnels and tubes and things. But for most of the project that I'll be talking about streams that are not underground, streams that are in fact above ground, and I'll show some great pictures of those in a little while. Flooding continues to affect communities in Northwest Florida. These are just a summary of some recent flooding that occurred as a result of a storm in September 2021, so just a few weeks from when I recorded this. It's just outlining many locations in the area where flooding was prevented people from being able to drive through the neighborhood, and some places where you could still drive through, but you might want to exercise some caution. They're still passable at certain times. So yes, flooding is a widespread impact, has widespread impacts on the community. The goal of this project that I'm involved with is first characterizing the streamflow dynamics. What happens when it rains? What is the hydrograph, that pattern of streamflow over time with the water rising and then receding? What are the dynamics? How does that happen? Can we describe how quickly the water level rises, how quickly it sinks, how quickly it recedes? And then to use this information that we gather from streams to find opportunities to reduce peak streamflow in urban creeks. And the urban creeks in particular that I'll be showing some data from today are located around in these red areas that I've outlined here. So these are the watershed boundaries for things like part of Tom King Bayou. There's a stream here in Navarre Park. I'll focus a lot on this one here. This is a tributary to Jones Creek that we call West Pensacola Creek. There's 8 Mile and 10 Mile Creek, Sugar Creek, and Florida Town. And also a creek that we call Metron Creek. So I'll show some information about those characteristics of those watersheds in a little while. Why do we have this kind of flooding? I think there's a few reasons for why. I alluded to this a little bit earlier, that, that some of the flooding that we see could be an effect of how we occupy the landscape. We're land creatures and we don't like being wet, right? It's an inconvenience when roads are wet, when water pools, so we often try to get that water off the landscape as quickly as possible. It's a real pain when water's coming in the house or covers the driveway, things like that. So we've developed things like hydrologically efficient roofs, right? We get the water off the roof as quickly as possible, down into downspouts or off the roof. We have affected the neighborhoods so that we get that water off the streets through these types of drains that we can see here in this image. And we have hydrologically efficient businesses, right? We got these parking lots that have lots of a drain. Here I am standing in a big empty parking lot. There's a drain right behind me there. We have these drains that take that water off the landscape as quickly as possible. And where does that water go? That water goes it goes through these conveyances, these subsurface conveyances, these giant culverts like this in many cases that are interconnected, take water down to some kind of a creek oftentimes. So this water, in this case, this is an outfall for stormwater, where as water moves off the road or off a parking lot, it goes into these pipes. In this case, it's disconnected. It's caused lots of erosion in the area as the force of the water over decades probably has caused this to erode substantially. And these big pulses of water moving off the landscape into the creeks can often cause flooding. This is a picture of an area where there's a creek somewhere in the middle here. A creek has flooded because it can no longer contain all the runoff that's provided from upstream. And that's not to say this wouldn't happen in the absence of development upstream, in the absence of parking lots, roofs, neighborhoods. It's that we see this more often because there's a much higher flush of water, a much higher peak flow that occurs as a result of all the water washing off this impervious surface. And there are other cases where water just can't infiltrate down into the ground. And this is something we see in some neighborhoods, especially in low-lying areas or areas where the soil is not conducive to water infiltrating very easily. Water will just sit on the landscape. So in some cases, the soil doesn't allow for water to infiltrate. The soil is already saturated. There's no stormwater conveyances, so the water sits in the landscape. This is a picture in Santa Rosa County. It's not exclusive to Santa Rosa County. This is a picture of the same issues in Escambia County as well. So I also think, just to kind of put this in context for this year, I collected a lot of stream flow. I'm going to show a lot of data showing water level changes different times of year, or I should say over the summer, especially over summer 2021. Just to put in context for what 2021 looks like, this is the annual rainfall that's occurred over the past 12 years, so starting 2009, 2010, 11, 12, 13, and so forth, to 2021. You can see in some years we have very rainy years, like 90 inches of rain. That's a lot of rain for a year for people who've lived other places. Right? It's not uncommon for there to be 88, 89, 90 inches of rain. So far in 2021, I'm recording this in early October. Through September 2021, we've received 72 inches. We got another 8 inches in the past few days. So there's a lot of precipitation that's occurs. We're probably going to end up topping off around 90, 100 inches this year. Yeah, and I think it's also interesting. So that this orange dashed line shows the average historically, maybe over the past 50 years, of about 64, 65 inches of rain. Over the past 12 years, it's been more like 72, 73 inches of rain. So it seems like people ask me, does it seem like we're in a wetter cycle these past few years? Yes, it seems like we're in a wetter cycle over the past few years. Something's going on so that we're a little wetter than we have been historically. I also like to put this just kind of in context for how fortunate we are here in the southeastern United States. There are a lot of areas where there's been a persistent drought for many, many years, right? We've heard a lot probably about this in the news, especially in the context of the Colorado River and the fires in the western part of the United States. We are not in drought conditions here. This is a map. This is an image of the National Drought Monitor, just showing the conditions showing various levels of drought through the western United States, through the entire United States, but especially highlighting the drought in the western United States. The red showing the most severe extreme drought, and then kind of gradations of dark red to medium red to light red to orange, yellow being the lightest. There's still being drought conditions, but not quite as intense. Yeah, we're not in that this year. Here. I think this is also interesting to show. I mentioned this earlier as well, that we tend to get rainfall in these really big events. This is precipitation. The distribution of rainfall is recorded by weather underground stations. So there are many people in our region who are hosts to a rainfall gauge. So they've got something set up in their yard or at their business or at the school that they work at, where it's recording rainfall, so that every time it rains, it takes readings of how much rain occurs. And those data then are through this Weather Underground program, are posted onto the internet. So we can look at, so anyone can go onto the internet and look at how much rain occurred in that location over the past day, over the past week, over the past month, over the past year. And this is just in this Pensacola Bay and Perdido Bay area. There are rain stations that people have recorded data at all these points here. These are the ones that happened to work through this period of Hurricane Ida, which was August 29th to August 31st, just about a month ago from when I recorded this. We can see the amount of rainfall. We think of the Hurricane Ida didn't hit this area directly, right? It hit kind of central, west central Louisiana, but we're affected by these bands of precipitation. If you think that the kind of the counterclockwise spinning circle as these arms of precipitation kind of move up and pass water up into off the Gulf. They move that moist air off the Gulf. A lot of it falls as precipitation in the area to the east. And that's what we see. You can almost envision how these bands of rainfall moving south to north came through here, dropped a lot of rain kind of through this area, a lot of rain kind of through this area, maybe not as much in between, a lot of rain. So I like to look at these images because they show how the distribution of precipitation occurred in this area. And yeah, there are some areas that recorded 10 to 13 inches, these dark blue dots, anywhere between 10 and 13 inches. My house is somewhere in this kind of in the 6 to 8 inch range. That's pretty accurate. It rained a lot that week. We have several streamflow stations then in this area. I'll show some data from in a little while. So a storm shortly after that, like 2 weeks later, we had another storm, similar magnitudes, a lot of precipitation again. This was Tropical Storm. Oops, I have this one labeled wrong. This one is yes, different data, slightly different data. But this in this case is Tropical Storm Nicholas, bringing again these bands of precipitation, similar orders of magnitude. So how does that affect creeks? Right, all that water rushing into creeks. I always like to look at things kind of under normal, kind of low flow conditions, kind of day in, day out operations for a stream. Then when it rains, there's this mad pulse of water that moves through. Here's a couple students working in my lab here. Caitlin and Savannah are putting in some instrumentation in 8 Mile Creek. You can see there's a bridge up here. We can look down. This is taken from about this pine tree here. Now this next picture, I'm looking at this reach of stream, but standing on the bridge, so that this pine tree here is the same as this pine tree right here. We can see like there's a lot of fine sediment. There's a lot of water kind of extending out into this vegetated area, which is probably like this here. There's water up. Maybe it's not quite as high as Caitlin's head here in this picture, but the water's pretty high. We also looked at conditions in another nearby creek, Sugar Creek. This is August 30th, 2021. Maybe this isn't the very high flows that occurred during this storm, during Hurricane Ida, but also a time of elevated stream flow. And so this graph is showing how the water level in Sugar Creek changed over the course of, this is over the entire summer, from May 19th until the beginning of September. So kind of through that Hurricane Ida period. And we can see that these rises in water level and quick recession. So we see a rise and a quick recession with precipitation. So it rains a lot, the water level rises very quickly, it stops raining, it drops just about also quickly, not quite as fast, but also very quickly. And this is characteristic of what we'd expect for small streams, right? It has a small watershed area, it's getting a big pulse of water moving through, and then it recedes very quickly. It does move a lot of stuff, right? A lot of stuff, and you can imagine a lot of debris moves through the stream channel during these types of events, such as, some of it could be very large, right? This is a trash can from somewhere upstream that's been deposited on the banks of Sugar Creek, along with apparently a lot of sand as well. I just want to get a sense for how quickly it rises and recedes. This is kind of distorted because this is over a three-month period, June, July, August, about 3.5-month period. So I don't think it really characterizes how we can't really see how fast things rise and recede. So I'm going to zoom in from this orange section for about a period of about a week. This is July 8th to the 15th. So it's about a 7-day period. We can see it flows. The water levels rise very quickly, then they recede a little more gradually. You can imagine it rains a lot, rains very heavy, it rises, and it stops raining, and it slowly gets back down. Not too slowly, maybe over the course of a day. Rises, and over the course of the next day, it drops back down. And this kind of characteristic of rising and receding is something that's common in these streams. So I'll show some data from Metron Creek, a creek we call Metron Creek. This is draining an area not far from my office here. In fact, this is in Pace, in Pea Ridge. This is the Metron Estates area. In fact, this is Pea Ridge Elementary School, if you're familiar with the area. This whole area drains off Highway 90 toward Pond Creek this direction. So the low point in the watershed is here. All this land drains kind of toward the northeast. And as it kind of washes off the landscape, it carries a lot of sediment. This is an area that's especially prone to that we found is especially prone to erosion, and that all the fine sediment that's carried off the watershed has historically been deposited in this person's front yard. This is right next to a small retention pond right here. A lot of the water doesn't move efficiently through the subsurface drainage network. That network, if you remember the big culverts that I was showing before, the water is not all moving through those culverts. That subsurface pipes, a lot of it moves off through the landscape and apparently is in this person's yard, in this front yard. This house was purchased by Santa Rosa County, partly because the people who lived in this house were having so much problems with flooding. Eventually, the county plans to take this house and demolish the house and extend the stormwater pond to the retention pond to store more water. And just show a sense to get a kind of a zoomed in version. This is that yard. We can see just how much material accumulates in the landscape. So there are subsurface pipes that wash down into this. In fact, on the other side of the street from here, there's a big stormwater structure that's supposed to be collecting all the water off the roads and things. You can see it's marginally effective, and a lot of the water ends up still in the street and carries with it a lot of sediment. But the creek itself looks pretty good, right? Considering all the problems in the watershed. The creek itself looks like a fairly healthy small stream. It's not too turbid. It does have issues of, you can imagine, with the small watershed and all the impervious. We'll go back a couple slides here. It's a relatively small watershed. It's not completely impervious. It's got a lot of there's a lot of the surface that allows water to infiltrate into the soil. But there are some roofs and parking lots and things, that impervious surface that does not allow water to pass through in the watershed. And the hydrograph is much flashier, right? The rises and recessions occur much more quickly than we saw in Sugar Creek. That's not entirely surprising. It is, like I said, it's a smaller watershed. It takes less time for that water to run off the landscape. This is over that same period we were looking at with Sugar Creek. The rises and recessions occur a little more quickly here. 10 Mile Creek. So 10 Mile Creek is not far from, earlier I was showing Sugar Creek, which is like right over here, flowing that direction, kind of off to the northeast. 10 Mile Creek flows southwest into 11 Mile Creek and then Perdido Bay. So, and this has a much larger watershed. This is on the order of a few square miles for its drainage, for its watershed area. We can see it actually has a defined blue line drainage network. And our stream gauge is located right about there. It's interesting. So I think it's a project. It's a stream where there's been some work done to try to stabilize the stream banks. So this is a restoration project, a stabilization project that was done in the early part of the early 2000s. Try to stabilize the bank under base flow conditions. What it means is that by putting all these large boulders in this relatively steep channel, there's no water on the surface. It all flows through the interstices of these boulders that were placed in the stream channel. Not ideal for habitat, for aquatic organism habitat, because there's no water on the surface anymore. But it is interesting in the sense that this is one of the few places where you get to see white water during high flow events in Northwest Florida, right? You could imagine this would be a lot of fun to raft or kayak down, right? This is probably one of only a handful of places where you can see white water for brief periods here in Temp Creek. The stream flow patterns, it's got a larger watershed. It's not entirely unexpected then that the water rises and recedes more gradually here. If we kind of put it in the context of thinking about what we saw for Sugar Creek before, these rises and recessions aren't quite as extreme as what we were looking at before. It recedes more gradually. It takes a little more time for that water to get back down to low levels. The changes in water level during heavy events, during very high levels of precipitation, the water level rises a lot more in this case, right? Up to 7 feet. It goes up, 6.5 feet, and then recedes back down over the course of a day or two. So we still see that pattern. It's just during these moderate events, the recession occurs more gradually. We have a couple interesting creeks that I'll show some data for now that are very small streams. This is actually probably about on the order of the size of Metron Creek we were looking at before. This is a creek we call West Pensacola Creek, and it's our stream gauge. It's not an officially named stream. We've called it West Pensacola Creek partly because our good friends at the West Pensacola Baptist Church have allowed us to put a stream gauge here and and look at what the conditions are like, what the water quality is like in this stream. And so it's provided some really interesting insights for very small streams that are ephemeral, essentially. They only flow when it rains in this area. And so this is our watershed. The stream flows north to south and then ultimately into Jackson Creek, and then into Bayou Chico. So stream flow, again, this is an interesting creek. So as I said before, when there's no rainfall, there's no water in the creek. It is an ephemeral stream. It only flows when it's raining. You can see some trash tends to accumulate in the stream from upstream. In this case, that's a bathroom vanity that's been deposited. But this is what the stream bed looks like when there's no water. When there is water, it's a pretty exciting place. And it's very, very fast, very big rushes of water that move through, moves a lot of stuff, a lot of fine sediment, a lot of other stuff gets moved through here as well. And it's kind of similar to what we saw with Metron Creek, very, very rapid rises and recessions that occur over the course of this 3 or 4 month period. But most of the time the channel's dry, it rains a bunch, rise, recession. In some cases, yeah, we can see even here, so in some cases it rains a lot, it rises very quickly and then drops off. It doesn't rain enough to cause maybe these high flows, but enough that there's water in the creek, it drops back down. I'll show I think one of the creeks that I find to be most interesting in this area is a creek that we call Tom King Creek, which flows into Tom King Bayou. This is in the Holly by the Sea neighborhood in Navarre. And it's really been interesting to look at the stream flow dynamics in this area. So there are 3 forks that make up Tom King, that flow into Tom King Bayou. So here's the bayou. It's bayou all the way down to here. And then there are 3 forks. There's an east, a middle, and a west fork. We've been looking at the water levels and the stream flow in this middle fork, the middle fork of Tom King Creek, we call it. And this is what it looks like. It actually doesn't look too different from Sugar Creek. I think that's a really interesting comparison. The watershed size, the amount of area flowing into the creek is about the same, or feeding into the creek at this point is about the same. The creek looks similar. It's about this wide, right? It's maybe 2 arms lengths apart, 10, 12 feet apart across. And when it rains, it sustains a base flow through most of the year. When it rains, the water levels rise like a small creek. Except it's interesting that the rise and recession of the water is a little different in Tom King Creek. It's much more gradual. I think this is really surprising, and I'll compare Sugar and Tom King Creek in a minute. But when it rains, the water level rises very quickly, but then it recedes very gradually over the course of weeks instead of that a day or two that we were looking at before. This is a graph this is Sugar Creek and this middle fork of Tom King Creek over a period of about 3 weeks. But you can see just how much more quickly. This Sugar Creek is this yellow line. The middle fork of Tom King Creek is the blue line. When it rains, water level rises. In Sugar Creek, it drops back down right away. In Tom King Creek, it recedes very gradually over the course of several days. Rains again, rises, recedes much more gradually than Sugar Creek. And in some cases, it's interesting. Also, these are 2 creeks on the opposite sides of our study area. One in Escambia, one in Santa Rosa County, And in some cases, we can see that it must rain in the Sugar Creek area and not in the Tom Creek, not in the Tom King watershed. So the water level rises in Sugar Creek. It doesn't rise in Tom King Creek. We just kind of have this continued gradual recession. But yeah, I think this is really interesting, just how different the rise and recession of our water levels are in these two creeks. So what does this mean for flooding? Flooding is certainly an issue in this area, and I think those issues that I described before, where in some cases flooding has a lot to do with the amount of water moving in from upstream, in some cases with the need for water to move off the landscape more quickly. This is a channel, a cross-section. I've chosen Tom King and Sugar Creek because these are the two streams where I think flooding is the biggest issue of the 10 that we're studying. You can kind of imagine the Sugar Creek flows along this green line here. This yellow dotted line is a cross-section. So I'm going to show an image in a second of the stream bed as we move from one side of the stream bank to the other through this neighborhood. So we can kind of imagine there are houses on each side, right? The creek is here. The ground level, there's a house on this side. The ground level kind of drops off. Or maybe in a floodplain over here, an area that floods often enough. The vegetation is a little different than it would be kind of farther up in the landscape, kind of in a more frequent flooding area. And down here, we've got houses on this side. I think one of the issues with Sugar Creek, one of the big challenges, is that there are houses that are kind of built in this area that floods fairly frequently. That if that 3 feet higher water level that I was showing in those graphs, Sugar Creek, maybe once or twice a year, water level rises 3 or 4 feet. That causes some water to move through this backyard and up into the front steps of the house on the other side of the creek, and that causes a lot of issues for especially along the street along that street that I'll go back here. The houses on this street here have a lot of issues with that. And so one of the things we're trying to think of is, well, are there ways that we can reduce the magnitude of flow moving through this area by changing the dynamics of essentially increasing the amount of water that sinks into the ground rather than washes off the landscape upstream. Yeah, this is kind of highlighting that. This is a picture I showed before. We can see, if you can imagine, 2 feet maybe is here, 3 feet starts to get into these people's backyards. And you can see their lawn is right here. The fence is right is not too much lower than the level of the creek, and the houses aren't too far back off that. So yeah, it creates some, drop my pointer stick here. It creates some issues with flooding in this area. And then there's issues with Tom King Creek. I present these as things that we're trying to figure out now, that hopefully a year from now we'll have some ideas for solutions, things that might be able to mitigate some of the effects of flooding in this area. In this case, when it rains, water sits on the landscape and slowly infiltrates down into the soil and ultimately making its way subsurface to the stream channel at a pace that is probably not far off from what would occur under natural conditions in a stream. That this gradual recession, in a lot of cases we talk about trying to reduce that peak flow that we were showing in Sugar Creek. In this case, we don't have as much peak flow. We have that gradual recession. The water is kind of slowly making its way through the landscape, either through the surface or through the subsurface, causing this gradual recession. And that gradual recession means that a lot of the area has water sitting on the landscape for a long time, and that creates a lot of problems for people who live in the area as well. So yeah, so it's an exciting place to work for a lot of reasons. There are other issues that are kind of beyond the scope of our project, especially in that a lot of these places, I mentioned this earlier as well, a lot of the places in this area that experience flooding are flooded not because the stream channels are not because it's very flashy and the water's flowing out of the stream banks or the water sitting on the landscape. It's that the streams have been buried historically and the water can't make it through the stream. The conveyances that were put in 50 years ago aren't large enough to accommodate all that runoff. And so there are a lot of issues with insufficiently sized stormwater infrastructure as well. Yeah, so especially in these urban areas, kind of this area here experiences a lot of flooding, and there's just no surface streams anymore. They've been buried. So it is an interesting place to work from that perspective as well. And so that's kind of a summary. I wanted to put this presentation together, just to kind of summarize where things are with our project, looking at water levels and stream flow in this area. I also have a video on green infrastructure in this area, the process of the types of projects that are designed to mimic natural processes that are designed to reduce those peak flows that I was talking about in Sugar Creek that have been very successful in this area. So I'll point out to that one as well as a video showing the water quality dynamics, which will be very exciting to explore as well. And then over the next few years, we'll be looking at ways to reduce these high flows that occur, maybe get some of the water off the landscape in places like that Tom King Creek to reduce flooding and improve the community's capacity to move through their neighborhood and the community resilience issues there as well. So I encourage you to check out these other videos and check back here in a year or so and see what we've been working on.